Okay, this is mass and volume, but you're going to be doing the 4 block vocabulary for mass. Sorry, this is mass and weight. You're going to be doing 4 block vocabulary for mass, so make sure you stop and make this notebook entry. Okay, weight versus mass, understanding the difference. What does weight describe? What does mass describe? You should know these, right? We did these already. Weight is the force of gravity on an object. Mass is the amount of matter in an object. Weight is measured in newtons or pounds. Mass is measured in grams or kilograms. Are they the same thing? No. But on Earth, they are the same thing. Because on Earth, the force of the Earth's gravity overpowers everything else, and they are the same. So they aren't the same, but on Earth they're the same. In science, they are not. In science, we are going to talk about mass and not weight. Okay. We also aren't going to use the word heavy when using measurements, right? What's heavy for one person might be lighter for another. It's an opinion. Mass and weight are both measurements. They aren't opinions. Okay. Mass is measured in grams. Weight is measured in pounds or newtons. So mass and weight are not the same, but they are both measurements. Here are your 4 different forms. Mass doesn't have any other forms of verbs or plurals, but these are your different languages, so use those for your other forms box. Okay, which cup has the least mass? What do you think? Take a guess. The cup with the least mass is the pasta, because it has the least number of particles. It can fit the least in there. Which cup has the most mass? The cup with the most mass is the beans, because it has the most particles. By the way, you just had 2 sentences, 2 complex sentences, using the word mass. Okay? 3 sentences in your notebook or 2 complex sentences. So you can use those. Which cup would feel the heaviest? The cup that would feel the heaviest is the beans, because it has the most mass due to higher density. We're going to start to talk about what density means. It's a ratio of mass to volume. Which has more mass, sand or water? The sand has 5.44 kilograms. The water has 7.24 kilograms. Well, that means the water has more molecules than sand, right? Is that a fair comparison? Not really. This water jug has more molecules because the jar is bigger. It takes up more space. What does it mean that it takes up more space? It has more what? It has more volume. Is that a fair comparison? Not really, right? It's a fair way to compare stuff or molecules in each because the volume is not kept the same. Okay? When I have different volumes, I can't really compare molecules and mass. To compare fairly, they need to have the same volume. We can only really compare mass for the number of molecules if we keep what the same? Volume. We're going to be talking about that ratio between mass and volume. We'll be making and choosing diagrams to show how many particles or molecules are in a certain volume. Okay, let's look at these pom-poms. If we find the mass of each pom-pom, it is no surprise that the bigger one has more mass. The bigger one is 1.8, 0.9, 0.3, 0.0. In fact, this tiny one is so tiny, it takes 6 of them to even show up on the scale, to even show up as 0.1 or a tenth of a gram. If we find the mass of each individual particle, we're going to use these as molecules, right? Then we see the largest pom-pom has the largest mass. But what if we kept the volume the same? How can we keep the volume the same? Well, we're thinking of those as particles or molecules. So if we put the molecules in the same container, then which one do you think has the most mass? Do you think this still has the most mass? And this has the least? Let's see. 6.2, 5.6, 5.0, 3.4. Yeah, the smaller particles are able to fit more into the same volume, so they have a larger mass. If we measure the same volume with different particles, we see the opposite. By the way, this one, the smaller particles or pom-poms are able to fit more into the same volume, so they have a larger mass. That is also a sentence. So we're going to practice comparing the measurements, numbers, and diagrams, picture model, of different solids and liquids, right? But we're going to use this idea to draw our molecules. Things with more mass are going to have more molecules in the same volume. Which material here do you think has the most mass? Metal, plastic, or wood? Well, which one has the most molecules? When comparing different kinds of matter, if the volume is the same size box, then more mass means more molecules or more matter. Low mass, medium mass, high mass. Mass and molecules can be compared the same if the volume is the same. What happens when we triple the mass of each? Do you think the metal still has the most mass? Yes. Mass increases proportionally with volume, and metal still has the highest density and molecule count. And this is this idea, if we keep the volume the same, and here's your rate proportional reasoning. We made each bigger by 3. We tripled each. Right? So, and when you triple the volume, you also triple the mass. That's why the ratio stays the same. What would happen if we cut them each in half? Even when we cut them in half, wood still has the least number of molecules, and the density remains unchanged. Okay? You're going to do this in practice today, putting some molecule models to blocks of wood, metal, and plastic. Good luck. Have fun.